As I did it in the last panel, if you all saw it, I do not have the ability to give all the accolades that all of these incredibly hard hitters have on stage. So I'm gonna let them go ahead and introduce themselves. Today, as you can see, we're going to be talking about, for this last panel that's gonna bring us on home and then take us home after this, we're gonna be talking about build and risks. And I would like, ideally, for you all to come away from this at the end with an idea of what you should be thinking about when it comes to risks. There's many different ways that we can look at risks. It could be engineering risk, it could be looking at different data risks. And then when you are building, trying to keep those risks at the forefront of your mind and recognizing that it's not after the fact that you want to be thinking about these different risks that we're talking about. So we've got an incredible group of panelists. I am going to start over here at Harrison and then just bring it on over. Go ahead and tell us who you are, Mr. Chase.
Hello, I'm Harrison, CEO and co-founder of LangChain, which is a developer framework for building LLM applications.
I'm Yaron. I'm a CEO of Robust Intelligence, a company that secures AI.
I'm Aakanksha. I'm at Google Deepmind, and I work on scale and efficiency for language and vision models. And I was leading PaLM.
My name is Benjamin Harvey. I'm the founder and CEO of AI Squared. I'm also the director of designing trustworthy AI systems program at George Washington University.
Wow, all right, and I'm Demetrois. So this is gonna be an awesome panel, I can tell already. When it comes to risks, as I mentioned before, there are a whole lot of them that we can look at. So Aakanksha, maybe you can just give us a bit of an idea of when you think about risk, what do you think of?
So when we think about risks, it's a broad definition. And it falls in line with some of the AI principles that we have. But basically starting with fairness and representation in the data that is used to train the models, and then going from there to like training models and testing the outputs for all kind of benchmarks and safety. So there's a lot of testing that goes into the model outputs even before RLHF to make sure that these models are are constructed properly. And then there is, of course, application-specific testing that has to happen. And every application and downstream application might have very different requirements. So that testing is very separate. So that's where I would start the conversation. Also, this is an ongoing field. So as we will discuss further, when these models are part of systems where you are chaining them perhaps with memory and other applications, then there are further risks that you have to take into account, including like, are you running insecure code or are you doing any data leakage? So all of those questions become even more pertinent based on which systems are interacting with the model.
So Harrison and Yaron, I see you shaking your heads or nodding your heads yes. Anything else you want to add on to this?
Yeah, I think I wholeheartedly agree. I think that the way that we think about risk is like we think that there are three categories of risk. There's operational risk, there's ethical risk, there's security and privacy risks. So we think about those in three different categories. And the reason you should think about these, or it's convenient to think about these in three different categories, because they also sort of tell you who in the organization is responsible for them. So, if we were meeting here like 2 years ago, we would mainly talk about operational risk. That's the one I think that like people in ML, and engineering would typically think about. So these are things where, traditionally you would be looking at, where could my model be failing due to kind of like operational reasons, where it's like unseen categorical, missing feature, these types of things. The ethical risk is like things that we started becoming, I think, as a community, more aware of. Maybe I want to say like a year and a half ago, when we're starting to think about bias, right, and models and whatnot, right, and then that goes into like different parts of the organization. Typically, parts in the organization that would care about compliance, that would care about legal, right, those parts. And then last, I think and not least, is security, right? And that is, for I think, something that is somewhere in between ML and security. That's newer to the security community, but now the security community is actively thinking about, about AI risk, and that's again different part of the organization. And that's like, those are things all the way from pickle file security, software supply chain aspects of it, all the way to prompt injections, adversarial attacks, these kinds of things. So those are kind of like, I think, the main three categories that one can think of.
Yeah, I think the types of risks that I think are newer, as was alluded to earlier, when you start chaining a lot of these models up with real-world systems, and you have them not only outputting text, but you're then using that text in a very specific way to do things with tools, whether that's run code, execute SQL, or stuff like that. And I think, yeah, to me that's very new, but that's probably, I don't know, to me that's the type of risk that I'm most interested in and also think can have a really big bad impact when you talk about, like if you think about AGI going wrong, right? A lot of it's doing stuff, and a lot of that is like applying the outputs of whatever its model is to like a real world action. And I think that's where a lot of the risk is introduced. And we're obviously very early on in that journey still, but I think that's kind of like, to me, a lot of the new, exciting, and very important type of risk to talk about.
Awesome. Yeah, go for it.
Just to add to that, in the action space, when we're using the models to take actions in the real world, a lot of the real-world deployments would rather go for scoring outputs, which constrains the set of actions that the AI can take, as opposed to open form generation. And that's one risk mitigation that people look at.
All right, cool. So, Benjamin, when it comes to foundational models in contrast to other AI systems, how do you think about the risks? And there's specifically, these foundational models which are specifically trained and then used for a particular purpose. What kind of risks are you looking at there?
Great question. So one of the things that you'll see, and I think the panelists up here have mentioned, is that at different stages of the machine learning lifecycle, there are different risks that could be introduced. And one of the things that's important that really separates kind of the traditional machine learning lifecycle, where you're a data scientist building a model that might be used and delivered to one or three different analysts inside of an organization, versus a very general large language model, is that as we are training these different types of models inside of these organizations, these models are being delivered in a way where the analysts are interfacing with them from a human-machine teaming perspective. And because of that, it allows us to have the ability to start identifying certain mechanisms of feedback, so that we could start to understand the actionability of the model, the relevancy of the model, things like how timely the information is actually arriving. And overall in an organization, it's really about trust that leads to adoption, right? So from an end user perspective, you're really looking at how can I increase the amount of trust to for overall increase in adoption. And that is really a component of all of those different areas of can I make the results more actionable? Can I make them more relevant? Can I make them more timely? Can I add additional contextualization that can increase the trust and increase that overall adoption?
I love that. All right, so it is, for me, very clear that when people think about different use cases with large language models, right now there are two gigantic questions that come to mind. And one we addressed in the last panel that I did, and it was all about ROI. And in this panel, it's very much about the risks and the trust, and when things go wrong, how they can go wrong. And I would be remiss to not mention my favorite part of large language models, which are hallucinations. And whoever was the researcher that came up with that name, props to you, because I can make jokes all day about that. Yeah. Like, for example, who hallucinates more, ChatGPT or your average college student? What? I don't know yet. So when it comes to hallucinations, how do you think about mitigating those risks? Because it could seem really real, and then you could put it into a commercial and put it out for the world to see that like this actually is happening, or like, oh, you can damage your brand quite heavily if you are not aware of what is going on with these hallucinations. So do any of you have any ideas on how to mitigate that and what you look at?
So first of all, it's a great point to keep in mind when you're building applications that these models hallucinate and they're actually overconfident in their answers. So they will hallucinate with so much confidence that even if you're not an expert in an area, you might read that text and you would be like, oh, that seems so believable. I totally buy that. So I think for information seeking, they're not quite there yet. It's an active area of research where some of the techniques include calibrating the models so that they can answer how confident they are, in addition to just spitting out text. There are other techniques which involve retrieval augmentation, where you put the right set of text in the context window. So those are some of the techniques for mitigation, but in terms of deployment, what's most useful is to have human in the loop who is an expert, and these models mostly acting as an assistant for generating text or whatever it is, like whether it's code, but there should be a human in the loop at this point in time to review what's being output, and they better be an expert and someone who can critique the model output is how I look at it.
Awesome. Yaron, I see you.
Yeah,
I see you wanting to go for it.
No.
What do you got? What do you got for us?
No, I think one of the things that you learn when you hang a little bit with the security community is that you learn that they have one of the set of the controls that they have is just don't use the product, right? Which is that's amazing, right? That's a very powerful control, right? And that's not a bad idea, right? Like for some things. So I think like on one extreme, I think that there is something about recognizing the fact that we're using models. These models can hallucinate by design almost. So we need to be thoughtful about the the applications that we're using them for, and then sort of, well, if my application cannot tolerate hallucinations, maybe I shouldn't use it for that application. I think that's one extreme, but I think it's also like a very acceptable solution in many cases. I think then there's a spectrum, right? All between, somewhere between kind of just accepting the fact that there are hallucinations or not, or just not accepting them at all and not using the model. But then, there's a spectrum in between. And I think that really one needs to kind of the best mechanisms to try to mitigate those is to try to be really focused and not ask like, how do I make sure that my model doesn't hallucinate, but more, how do I make sure that for the specific tasks that I care about the model getting right, how do we, try to design like kind of very well-articulated validation, rules or, firewalls or whatever that, that really nail down the, the validations of the things that we care about. So either don't use it, at all for the, if you have sensitive applications that you're worried about hallucinations, or formulate the problem a little bit better, be more precise about the things that you really, really care about, and then build the right mechanisms and controls for those very specific things.
And what do those mechanisms look like? What are you seeing as far as like the controls?
Again, I think that like, you can imagine kind of like an application for like a, maybe you have a commercial application and you really care about making sure that the, now the model doesn't hallucinate about price, right? Or doesn't hallucinate about, maybe about URLs, right? And then it becomes, from like this very big, broad problem of like hallucinations to solving a very specific problem. And that very specific problem that you're then trying to solve is you're trying to do like a lookup, right? Almost to sort of see whether that URL actually exists or not, right? And that's a much easier problem to solve than, to sort of, go on, this heroic, kind of fight against, AI hallucinations.
All right, I like that. So, Harrison, I wanted to ask you, I feel like there is a generative AI apps stack that's forming. And I want to ask you because it feels like LangChain is smack in the middle of it. And when you think about, okay, if there is this stack that's forming, what in your eyes are the building blocks as you're trying to build your generative AI use case?
Yeah, I mean, I think it depends a little bit on the application, obviously, but I think at the core of it, you've got the language model, and so I think there's a lot of choices there. OpenAI is probably the one that people are using most, but there's lots of there's a few private alternatives and there's a bunch of open source alternatives. I think a lot of again, it depends on the use case, but a lot of the use cases we see are some type of kind of like retrieval augmented generation or grounded generation, and so that generally involves a vector store. That generally involves an embedding model. And I think another interesting thing is also, and there's a bunch of different things that you can choose between there. But I think another component is actually the UI for it as well. And I think like there, as kind of mentioned, like LLMs aren't great for every use case, and a way that you can make it better besides improving the underlying model is to improve like the UI and the UX of the things as well. And so I think things like showing intermediate steps, showing the retrieved documents, help build some of that trust, help people who are looking at answers validate whether it is actually correct or not. And so I think, there's a bunch of, there's a few kind of like existing players like Gradio and Streamlit that have kind of like got into this space with some really interesting templates. There's also new players like Chainlit, which offer kind of like this intermediate thing. I think the UI is maybe like the most underexplored and underdeveloped part of the stack. Like I feel like everything else is like relatively kind of like standard, but I think like everyone's doing chat, and chat's hopefully not the only UI for these things. And so I think, I think there'll be some interesting kind of like UI frameworks to emerge to help with a lot of this.
Awesome. Anybody else want to take a stab at that?
Yeah, so when you think of some of the co-pilot style integrations, right? So a lot of organizations that we work with immediately from a frontline worker perspective in financial services or my background, I did 10 years at the National Security Agency. We work with tons of analysts, and what they talk about is even if you develop a new application that's outside of their workflow, even if they have to do that context switching from one application to another, they'll never use it, right? Because it's out of their workflow, and when they want to make a decision on the data and it's out of context, they won't use it. So one of the things that is really important for these analysts that may use one or two tools on a day-to-day basis, and they don't use anything else, is really trying to figure out how do you integrate these large language model results directly inside of the workflows of the one or two tools that they use on a day-to-day basis. So to your point, I think it's really important not only exploring kind of the one-off applications for the conversational AI, but trying to integrate the results directly into workflows of those users.
I think there's also, like adding on to that, I think there's another type of UX, which is interesting to explore, which is maybe like the no UX paradigm, or basically just run things as background processes. And I think that's also relevant for this discussion around risk, because if you think about a chat, there's a very real like expectation on the latency that you can induce. But if it runs in a background process, like there's less of an SLA on like an email or something. So you can maybe do a lot of fact checking with like there's a bunch of research using LLMs to fact check kind of like themselves, doing some reflection steps. And so for UXs where it's just in the background, it's not in the foreground, you can maybe do more of these and increase kind of like the reliability with that as well.
Awesome. All right. So I like it because normally I'm doing this virtually and I can't tell if somebody wants to talk or not. And so then I got to call them out, and then somebody's like, oh, no. And here I get to see. They raises the microphone to their face and their head. And so then it's pretty obvious.
I will say this. Okay, so here we go.
I knew it.
I'm sorry. I think there's I think we just have to be mindful of LLMs like checking themselves, right? I think it's
Ooh, tell us more.
I think that we I think that we're aware of the fact that like there's risk in using LLMs, and when we're using LLMs to when we're sort of using out of the box LLMs to test test LLMs, and I think that we've seen evidence of cases where that can go wrong. So I think that is yet another risk that we have to be mindful of. So.
So basically, don't rely too much on the LLM that lied once, may lie again.
Yeah, I think we just need to be, we need to be thoughtful about it. We need to build like kind of tools that are purposefully built for these tasks.
And so that brings up the next point, which is kind of like common pitfalls that you'll see. And I think that one is a clear case of people saying, okay, well, if we can just get the LLM to evaluate its output, then we should be good. And later down the line, you realize that you're not good. What are some other things that you've seen along the way, and you're like, yeah, this is being taken as good practice, but may not be that useful? And I see a few of you kind of having to think. This wasn't on the pre-recorded questions. So now they're starting to go like, hey, he's throwing a curveball. Ben, you think of any?
I think one big area for a lot of organizations is they're really trying to increase speed to market right now for these large language model capabilities. And we were in a meeting with a CEO, and he was talking about the importance for him to accelerate the AI and machine learning. And he talked about his board of directors, and they told him that he needed to take part of his pay and figure out how to increase the amount of AI that was in the product for his organization, right? So there's a lot of emphasis on trying to speed to market. And what we've seen in two different types of organizations, in highly regulated organizations in financial services and top secret classified organizations in the intelligence community, is they do a really good job of running observational studies first, right? So even if they're trying to increase the speed to market, they're going to slow down to do an observational study first, where they're gathering feedback from a handful of users inside of the organization, where they're tuning and retraining before they deploy to a larger, hundreds of thousands of end users that need to use the technology. So even though that these organizations are trying to, accelerate how quickly they're getting the AI and machine learning results from the large language models in the hands of those end users, it's still extremely important to have that human-machine teaming aspect up front, where you're starting to gather that feedback, because ultimately, if you can't kind of gain that trust from that study and then scale it in a way where you have that trust across the organization, you won't get adoption anyway. So it's really important to kind of have that two-step process.
Excellent. So I want to be mindful because we have just a bit of time left, and I want to make sure that you all can ask questions. So I see a few hands up already. I'll give my microphone over. It's going to be like the equivalent of putting myself on mute, and I'll let you all ask the questions now.
Okay, so as you're doing this calculus, the risk versus reward of the large language models, the calculus risk versus reward, along the way with the training, at what point, or what are the top 2 or 3, either way, that makes it clear to you that the risk is exceeding the reward and you need to take a different path, or that the reward is exceeding the risk? What's the top 1 or 2 or 3 in each direction that leads you to go one way or the other, that the risk exceeds the reward or the reward is exceeding the risk?
I mean, I think honestly, a lot of what we see is that there's not great, I think people are struggling to find product market fit for a lot of these applications in general. And so I just don't think the reward for a lot of things is that high. Especially if we're talking about some of the tool use and agent stuff that can introduce some of this risk. There are a lot of demos on Twitter of using agents to do various things, but I just don't think they're good enough to be put in production. And it's not necessarily even because of the risk at this point, I don't think. I think there's just a gap in going from prototype to production. And so, this is a roundabout way of saying I just don't think the reward in general is that high for a lot of these more complex applications, which is generally where LangChain kind of plays in, so that's where I have more of the visibility.
Yeah, and I think it's not different from what we know from basic ML, right? If you can do it with the decision tree, then do it with the decision tree. If you can do it with linear regression, great, do it with linear regression. Don't do it with a a deep learning model. And I think it's not different here. So I think the first question that people need to ask themselves is like, when they're using an application, do I really need the state-of-the-art LLM with all the risks associated with it? Maybe I do, maybe I don't. But then basically try to find I think the simplest model that you could use. And this is where I think the open source community is going to be so powerful, right? Because I feel like so many people are now are very empowered to build their own LLMs for their very targeted specific applications. And I think that's going to ultimately what that would do is reduce risk.
I think we got time for one more question.
Thanks. First, Demetrois, you're even more fun than 2 weeks ago at MLOps, so amazing. I'm from the hedge fund community, and as Benjamin pointed out, there's a lot of regulatory, it's just very strict, right? And there's been this balance. There's a pressure from investors on are you using ChatGPT yet? On the other hand, SEC and other managing directors are maybe lean on from the risk side. But I'm thinking there's a lot of untapped risk, untapped opportunities, vector search or summarization. There's a lot of fundamental research you could do, or quant. So I'm thinking traditionally ML, you do a lot of confidence intervals, right? That or credible intervals. That is more important than the actual point estimate or the prediction. So I'm thinking here, what are your thoughts on some kind of probability beyond just the token next word prediction, but just the actual, here's the answer, here's the closest match. Why is that? Besides this chain of thought, but an actual number, some kind of probability that is intuitive for the layman to kind of understand.
So there's some interesting stuff around asking the language model to output kind of probabilities, but I think most of that has shown that they're not super well calibrated, and I think that's what I've seen empirically as well. I think they're just overconfident in a lot of cases, and they're also biased towards certain around the this gets back to the point of having LLMs grade themselves, but they're biased towards certain places in the thing. I mean, I think what we basically see people doing, and this is kind of related to getting a confidence estimate, is when you start from scratch for most cases. And I think that's the power of the generative models. They can do everything. Yes, you could train a classifier, but instead you could just prompt the language model in this way, and you can get up to speed really fast. The issue then is how do you know how well it's doing? And I think what we see people doing there is just building up a data set of test cases over time and then running against that. And so when you change the prompt or whatever, you kind of just look to see what happens on your 10, 15, 20 different test cases. And I think that's it's not exactly what you asked, but I think that's how we see people getting a general sense of how it's doing on a task in general. Yeah, a combination of human in the loop, combination of testing basically, and this also gets to I know we've talked about kind of LLMs grading each other as well, and I think it's not perfect, but I think one of the things that it does do is it can be a guiding light for where the human should focus their effort. So if you have kind of 1,000 data points, maybe you don't trust the LLM. And I don't think anyone who's doing LLM evals trusts it completely to give a grade of 0.93 or something like that. But I think what it can do is generally highlight data points, and then you have a human go in and look at maybe 10 data points instead of 100. And I think I think we're still so early on in this journey, and I think a big part of it is just getting that iteration speed up. And so having a way to measure that confidence is really important, and the way we see people doing that is just having this data set of 10, 20 examples.
Just for, we have, there's actually a lot of good academic research on conformal predictions that do exactly this. They give you not only prediction, but give you the confidence around that prediction, and there's a very solid theory behind it. I think that we haven't seen it as much applied for large language models, but I'd be surprised if we in the coming machine learning conferences we wouldn't see that line of research get adopted to this. So I think if we just sort of continue on seeing what comes out of the academic community, I think we're going to see exactly that, and I'm sure that it's going to be very interesting.
All right, I guess that is it. Everybody, let's hear a huge round of applause for our panelists. Thank you all so much for joining us tonight.